So in the last section of this unit, we're going to look at the relationship between sine and cosine. And you might have kind of noticed it already, but we're going to dive into it and investigate it a little further in this lesson. So in this first example, we're given a right triangle below. We're going to determine the following values in the table. So the first thing we need to determine is the sine of x. So you're going to start at our angle and label your sides. So start your angle, go across. That's our opposite. Go to your 90, go across. That's your hypotenuse. And your guy left over is our adjacent. And remember, whenever we're dealing with sine, cosine, or tangent, we're always going to use SOHCAHTOA. So make sure you write that down. We're finding the sine of x. So the sine of x is opposite over the hypotenuse. Well, our opposite is 3. Our hypotenuse is 5. So the ratio of sine is 3 over 5. The next one, we're going to find the sine of y. I'm going to keep dealing with x though, so we don't have to keep moving our sides around. So I'm going to skip the next one for right now and move on. We're going to find the cosine of x. We already have that, everything labeled with that angle. So to find the cosine of x, and cosine is adjacent over hypotenuse. Well, our adjacent is 4, and our hypotenuse is 5. So the cosine of x is 4 over 5. And if you notice, always double check. You can't simplify those fractions. So always simplify if you can. In this case, we can't. Now that we found all the ratios for x, we're going to find the ratios for y. So we're going to start at our new angle, y. Whenever we train angles in the same triangle, the opposite and the adjacent just flip-flop. And the hypotenuse is always going to stay hypotenuse, and this is so embarrassing. It's so hypotenuse. A little excited. There we go. Rearrange my letters. Okay. So to find the sine of y, again, sine is opposite over hypotenuse. So our new opposite is 4, and our hypotenuse is still 5. To find the cosine of y. Again, cosine right here is adjacent over hypotenuse. Well, our adjacent is 3, and our hypotenuse is still 5. Now that we found these values, we can use them to answer these questions. What did you notice about sine of x and cosine of y? Take a minute, take some seconds, think about it. What did you notice about the sine of y and the cosine of x? So you're looking at your table. Sine of x and sine of y. Sine of y. Cosine of x. What are you noticing about these values? And you should be noticing that they are the same. Are the same. And B says, what is the sum of angle x and y? And what do we call these angles? Well, let's first figure out the sum. So think back to that first unit. We know all the angles of a triangle add to 180. So we know x adds to plus y plus 90. All three angles will add and it will equal 180. Well, to figure out the sum of just x and y, move the 90 over. So we know x plus y equals 90. Okay. So we know x plus y, their sum, and sum means to add. Their sum is always going to be 90. Okay. Well, we know angles that add to 90 degrees are called complementary. You know, x and y are complementary angles. Well, what can we conclude about the relationship between the sine and cosine of complementary angles? We can conclude that they are the same. We know x and y said the sine and cosine of those angles were the same. If you have two angles that add to 90 degrees, the sine of one angle is always going to be equal to the cosine of the other. Okay? Every time. In reverse, if the sine and cosine of two angles are equal, then we can say those angles are complementary. In other words, those angles are going to add to 90. So if the sine of one angle is equal to the cosine of the other, then we can say we know those two angles are going to add to 90 degrees. Okay? So if we look here, in example 2, it says find the value of x that makes each statement true. So if we look, in A, it's saying the sine of x, so the sine of one angle, is equal to the cosine of another. Well, when that happens, when the sine is equal to cosine, we know those two angles add to 90. So we know whatever x plus 25, that's going to equal 90 degrees. So when you have a setup like this, you just take the one angle, take the other angle, add them together, sum them equal to 90. And then you just solve. We'll solve for x. Move over to 25. 90 minus 25 is 65. So that other angle would be 65 degrees. And you can even see this if you check it in your calculator. So look at our calculator and take my calculator out. And this is one way you can check your work. Okay, we're going to take the sine of 65 because we found that x is equal to 65. So we're going to take 65 and plug it into x, and we're going to see if it's equal to the cosine of 25. We're just going to check it. So we say sine of 65, we get that decimal. And now we're going to take the cosine of our other angle, 25. We get the same thing. The sine and cosine are the same. Okay? That's one way of checking your work to make sure you did it right. When you find the sine, you find the cosine, and you get the same value. It's super tempting to say that because the sine and cosine are equal, then those angles are equal. That's not the case. They add to 90. They're complementary. So that's the hard part you have to remember. Okay. If we take a look at B, the sine and cosine are equal. So we know those angles add to 90. So we're going to say 80 plus x equals 90. And then you just solve. To solve for x, you just move over the 80. Solve like a normal equation. 90 minus 80 is 10. So that other missing angle is 10 degrees. And again, you can check this with your calculator. You can find the sine of 80 and see if it's equal to the cosine of 10. So we're going to do sine of 80. Got that decimal. We're going to find the cosine of 10. We got that decimal, exactly the same. Now one more. And again, you see the sine is equal to the cosine, so we know those angles are going to add to 90. So we're going to say the first angle plus the second angle. I know it's a little different because both angles have an x. The process is still the same. You're just going to do a few more steps to solve. You're still taking the first angle, you're adding it to the second angle, and it's still equaling 90 degrees. You solve x plus x is 2x. Combine the like terms first. And then solve. Move over to 10. 90 minus 10 is 80. Divide by 2. We can check this in our calculator. Plug 40 in for both x's, so we get the sine of 40 is equal to cosine of 40 plus 10. We put 40 and plug it in, and we know 40 plus 10. That's really saying the cosine is 15. Check it out, plug it in. Cosine of 40. Oops, not 4, 40. You get that decimal. Cosine of 50. We get the same decimal. So we know we did our work correctly. So that's one way you can check using your calculator. If you need to, go ahead. Watch the video again. If not, get started on the practice.